Now we have the hydrolase. So it is an enzyme that catalyzes a hydrolysis reaction in which the addition of water causes the bond to break. Okay? So an example is the carbohydratase. So the breaking the glycosidic bonds in the oligo and polysaccharide. Then we have also the proteases, the breaking of the peptide linkages in proteins. So this is an example of hydrolysase. So this reaction is catalyzed by the enzyme maltase. So we have the maltose. So we already know that this is what? A disaccharide linked by a glycosidic bond. So this is the glycosidic bond in between the two structures. So upon the addition of water, we have this, the second reactant. What happened? Maltose is made up of two molecules of glucose. So when water is added to it, it will produce into, yes, two glucose units already. It means that this bond, the glycosidic bonds, is already break. Okay, that's why it produces a glucose and another glucose. It is already highlighted on the reaction. Now we have the Ligase. So it is an enzyme that catalyzes the addition of a group to a double bond or the removal of a group to form a double bond, okay, in a manner that does not involve hydrolysis or oxidation. So we have an example. We have the dehydratase, which affects the removal of the components of water to form a double bond. Then we have the hydratase, affects the addition of the components of water to a double bond. So this is an example of Ligase. We have the fumarate as one of the reactant and also a water. So it is catalyzed by the enzyme fumarase. So what happened to fumarate? It produced into L-malate. The double bonds already disappear. Okay? Then the water is also attached on the fumarate structure. That's why the double bond between the two carbons already disappeared because it already bonded to a one hydrogen and to the one OH group. So it produced the L-malate. Then we have the isomerase, an enzyme that catalyzes the isomerization or simply the rearrangement of atoms, okay, of a substrate in a reaction. So converting it into a molecule just isomeric with itself. So there is only, take note, in isomerase, one reactant and one product, okay, where isomerases are operative. So a good example is this one, the isomerase reaction of the 3-phosphoglycerate with the help of the enzyme phosphoglyceromutase. So it only involves the rearrangement of its atoms, molecules in the structure. So from the reactant, the phosphate is located on this part, the CH2O. Now, it produced the 2-phosphate glycerate. So the phosphate group and the hydrogen atoms already, what? They just exchange. Let's say they're partners, okay? The phosphates already bonded to the O on the CO structure. Then the hydrogen is already goes to the CH2O. Okay. Now, lastly, we have the ligase. So it is an enzyme that catalyzes the bonding together of the two molecules into one with the participation of the adenosine triphosphate. Adenosine triphosphate or ADP involvement is required. Why? because such reactions are generally energetically unfavorable and they require the simultaneous input of energy obtained by a hydrolysis reaction in which ATP is converted into adenosine diphosphate. So this is a good example of a ligase. So our two reactant on this reaction, we have the pyruvate and the ATP. So this reaction is catalyzed by the enzyme pyruvate carboxylase. Okay. So ligase, it bonded together, or it bonds together a two molecules. So we have the pyruvate and the carbon dioxide. So as you can see, it produces a oxaloacetate, wherein carbon dioxide is already combined on the pyruvate structure. And the ATP has been reduced into adenosine diphosphate, and it also produces a subproduct, which are the phosphate group, which came from the ADP and a H plus or H plus ion. So this is the ligase reaction. So this is the table for the summary of the 6 main classes of the enzymes. So oxidoreductase, we have the transferase, hydrolysis, the lyases, isomerase, and the ligase. So these are the selected subclasses and the type of reaction they catalyze. Okay, so this is the summary.